Chapter 12, Number 17. Kepler 62e is an exoplanet that orbits within the habitable zone around its parent star. The planet has a mass that is 3.57 times larger than the Earth's and a radius that is 1.61 times larger than the Earth's. Calculate the acceleration of gravity on the surface of Kepler 62e. So we'll draw our little planet. We'll talk about somebody sitting here, obviously not to scale, and we have some radius with some mass. And we are told that the radius is 1.61 Earth radii. And the mass is 3.57 Earth masses. And we know that on the surface of a planet, the mass times g, right, what we've been calling F sub g, has to be generated by the gravitational force due to Newton. And so we have g, mass of the planet, mass of the thing, over the radius squared. And that says that our effective g at the surface is g, mass of the planet, over the radius squared. So our brute force way is to just throw those numbers in, which is easy enough to do. A somewhat more elegant way to do it would be to use the proportions that were given to us. So we would do something like g times 3.57 masses of the Earth over 1.61 radius of the Earth squared. And the reason for sort of doing that is that I can do a rearrangement where I'll say that I have 3.57 over 1.61 quantity squared, and then left over was everything still in green, g times mass of the Earth over the radius of the Earth squared. And the reason for doing that is that this bit, that's g on Earth. All right, so we'll call this g on Kepler. And g on Earth we know. So we'd have 3.57 over 1.61 squared times 9.81 meters per second square, which turns out to be 13.5 meters per second square. And that was a lot faster than getting all those numbers and grinding them out. Although, to be fair, if you actually took the thing in the yellow box and you compute it, you don't get 9.8, you get 9.72. So even though this is a solution Walker gives in the back of the book and the way he talks about it and the way I would do the problem, it turns out it's actually a little bit bogus, and you should really be careful. The concept is right, but the thing in the yellow box isn't really g because of some various effects like differing density of the Earth and so on.